Hello and welcome to the 10th ever episode of the DevOps Directive Office Hours. It's been a little while, but I'm glad to be back, and I think we've got a fun episode today. We'll be working with Pulumi and specifically the automation API within Pulumi. And so for today's guest, I have Lee Briggs, who is a developer advocate with Pulumi. How are you?
I'm good, thanks. Yeah, just back from vacation, so good to dive into something fun before yet another vacation. I've been at Pulumi now over 18 months, which in the current world climate feels like it's been 5 minutes. But we're going to be looking a little bit at the different ways that you can use infrastructure automation to provision the infrastructure that your application is dependent on. And I'm really excited about doing it. We're going to be using Python today. Pulumi supports multiple different language SDKs. I think we had a chat beforehand, and then, Python is something that you're pretty familiar with. So hopefully some of the concepts that we'll be kind of going through will make sense. And I think it's going to be a fun experiment.
Awesome. Yeah, I think most of the audience is probably familiar with the concept of infrastructure as code, but now adding this element of building an API around that to abstract a little bit of that away from the development team is an interesting one that I think will be a cool thing to dive into.
Yeah, and I feel really passionate about this. Like as a little bit more about my background, I started out as in the industry as a kind of system administrator, so writing Python and Bash scripts 10 to 15 years ago. And obviously, as the industry has changed, kind of moved into cloud computing and containers and all those other exciting things that you cover on your channel every week. And the kind of traditional way that you would provision infrastructure is that you would write a bunch of configuration and then put it into a CI/CD pipeline, whether it's GitHub Actions or Amazon Code Pipelines or something like that. And I think this approach kind of is a little bit more user friendly, especially if you're supporting those users who are more used to writing applications and they still need to provision infrastructure. What you can do is abstract some of that complexity away to make their lives a little bit easier. And hopefully you'll see an example of what that looks like. The final thing that I'll say before we dive in is that if you're not really familiar with, if you're familiar with kind of doing DevOpsy things with infrastructure using configuration languages, some of this stuff might seem a little bit intimidating at first, but I'd like to just say that I felt it was intimidating once upon a time, and I felt that like kind of writing this infrastructure stuff in these languages really was a little scary, but kind of getting hands-on, doing something that I already knew, i.e. cloud computing, in a language that I wasn't necessarily familiar with, like Python, I've really leveled up my skills and I feel much better. And I'm now writing infrastructure configuration in 4 different languages on a day-to-day basis. So, if you're one of those people who is following DevOps Directive to learn every day, I think this is a great opportunity.
Perfect. Well, I'll pull up our screen share and we can dive right in. Anyone who is watching along, feel free to ask questions along the way and I'll pull them up. I see Carlos in the audience. Hey, Carlos. Glad to have you here.
Yeah, so I think we decided I'm going to drive today. So there's a couple things that I've done to kind of make sure before I actually get started. There's a couple things that I've kind of taken care of beforehand. And so the first thing to be aware of is that I've got some valid AWS credentials. So I'm logged into AWS and I can actually provision things, and I can do AWS S3 LS. I can list a bunch of different buckets, and you can see some of my colleagues are making use of the cheap S3 buckets in AWS. And then the other thing that I've done is I've decided where I'm going to store my Pulumi state. And there's a couple of different things that are available to you here. The command that you use is Pulumi login. And by default, we will store state for you. We have this free tier
Mm-hmm.
that will allow you to store resources. It's free for individuals, and it's free up to a certain number of resources for teams. If you do not want to do that and you want to stick down the open source path, you can either store your state locally using the login command, or you can use an object storage like AWS S3, Google Cloud, and Azure to actually store your state. I'm going to use the Pulumi service today because it's just easier and I don't have to configure an S3 bucket to do it. And so I can verify who I am by typing the Pulumi who am I command. So I'm
Nice.
logged in as my user. Obviously, I've installed the Pulumi CLI as well. Like that's important, but it's actually going to be interesting because we're only going to use that for the first part. Make sense?
It does. One quick question comes to mind. Presumably, if you're using the hosted version of the state management, it handles locking for you. Is that true or does it not?
It does support locking for
Okay.
you, but also as of about 3 or 4 months ago, the locking is also handled by the object storage as well. You have to set an environment variable, which I do not know off the top of my head because it's currently in preview. But that will soon be part of the CLI as well. The reason that we didn't support locking in the open source storage before is because not all S3 compatible storage was strongly consistent.
Right, S3 with
And
AWS, you have to do a Dynamo for Terraform at least. You have to
yeah,
do a
you have to.
DynamoDB
Yeah, you have to
instance.
use
Yeah.
a third thing, but like Amazon did a huge blog post, which is like a huge technical achievement where they made S3 strongly consistent, and so now we use S3 as the locking mechanism as well, and it works great. Lots of our users are using it, and so you get all of the benefits of locking, making sure that only one person is updating a stack at a time, basically.
Super cool.
We also have lots of other awesome features in the service. I'm not going to talk about those today, but I would strongly recommend trying it out. I got to put my Pulumi employee hat on for just a second there. Okay, so what we're going to do is we're going to bootstrap our Pulumi program, and this is generally the path that you would take in most situations. So you'll see I've created a directory here called DevOps directive. DevOps directory directive. It's empty, and so if you think about how you would set up a normal Python program, you might create a requirements.txt, you might create a virtual env. All those things are general things that you would do in a Python program. Pulumi is going to do a lot of this for us. So what I'm going to do is type Pulumi new. And if I type Pulumi new, you get this lovely drop down, which will show you all the different languages and templates that we have. I am going to choose AWS Python. If you already know what you're going to use, you can just add this after the Pulumi new command. So you can just type Pulumi new AWS Python. And if I hit enter here, it's going to start asking me for some information. So it's going to ask for a project name. By default, it sets it to the name of the directory. I'm quite happy with that, so I'm going to hit enter. And then it asks you for a description. Super useful if you're doing collaboration things. Like I've certainly run into infrastructure as code implementations where I'm like, what is this actually doing? So a description is usually pretty useful. Because we're just kind of doing an example today, I'm going to use the default. And then the final thing that it's going to ask you for is a stack name. And stacks are reusable implementations of Pulumi. We're going to try that out in a little bit if we have time. Just for the sake of this particular exercise, I'm just going to use the default of dev. And what's going to happen is it's going to then prompt me for the required inputs. So like the Pulumi SDK, sorry, the AWS SDK has some required information, and Pulumi will like say, we know that we need to set the region. I'm going to use US West 2 because I've had some bad experience with US East 1 in the past. And so I'm going to use US West 2. And then what's going to happen is Pulumi is going to set all the boilerplate up for us. So it's going to create a virtual environment, install all the dependencies in that environment for us, and create all the files that we actually need to actually get started, which I think is a pretty nice experience. I am biased, of course, but it's much easier than kind of having to remember a bunch of different commands that I have to run in order to get started. So this Pulumi new command is usually the first step in kind of getting off the ground with any Pulumi project.
Cool. Yeah, makes sense. And then we can take a look at what it actually installs in the requirements file, right?
Yes, so I'm just going to wait for this to finish pulling from the internet. Obviously, it's going to pull a bunch of different dependencies. Some of them are already cached, and then some of them aren't. And it's told me that my project is ready to go. So I'm going to switch to my VS Code IDE, and you will be able to take a look at some of the different things that it's adding in here. So in our requirements.txt, we have two dependencies, just the Pulumi SDK and then the Pulumi AWS SDK, which allows us to actually interact with AWS itself. We have lots and lots of different providers. So if you're more familiar with Azure or Kubernetes or Google Cloud or DigitalOcean or anything like that, all of those are available. And it's just as simple as adding Pulumi-Azure in here and setting your constraints and doing a pip3 install, and you will get all the dependencies installed for you, which I think is pretty awesome.
Nice.
The other things that are kind of unique to Pulumi and not necessarily a Python project, you get this pulumi.yaml, which will have the project name and, if you remember, our description as well. The one thing that we didn't specify is the runtime. This is because we support multiple different languages. We have to actually specify to Pulumi which runtime is going to be used, and then there's some options. So if you are the kind of person who has a global virtual env that you want to use for everything, you can specify which one you want to use here. I personally like to keep these constrained to different projects so that I can manage my dependencies a little bit more carefully. And then there's another YAML file, which is our stack configuration.
And so is that just a relative path to where that VM is living?
Mm-hmm.
Okay.
Yeah, so we can see here we've got this
Yep.
VM directory here, right? So if I wanted to do home VM or something along those lines, then I
Sure.
could do that. But right now it's just in this VM directory.
Yep.
And then the final thing is that we set our AWS region, and you'll notice this went into a file called pulumi.dev.yaml. This configuration is stack specific, and so what that means is that you can create a Pulumi program, and you could do something like target at a dev account, and then create a new stack and target a production account, and you can reuse the same code. And so depending on how much time we have left at the end, I'll be able to show you an example of that.
Perfect.
Okay, so we've got a very, very simple Pulumi program that it's created for us. And all this is going to do is create a my bucket program and export the bucket name. We can have a look what that looks like. Clear. Pulumi up.
Presumably that's going to fail because of the name of that bucket. Or no, it's going to generate a random name.
It's going to generate
the
a
internal
random name. Yes, that's a great lead-in. And so if we take a look at the details here, Pulumi does something which is interesting in infrastructure as code, is it adds this unique prefix to every resource unless you explicitly set the name. And the reason it does that is because lots of different cloud providers have immutable APIs. And so what this means is that by adding this random prefix at the end, we can say that if we ever make a change to that particular resource that is immutable, it can create a replacement for perhaps behind a load balancer, and then kind of take down the other one afterwards, which will kind of allow you to do lots of blue-green deployment instances. So this is obviously the most basic of Pulumi program. It's just an S3 bucket. We're going to be a little bit more elaborate today in our Pulumi program because we want to make something that's going to be reusable across a bunch of different implementations. So the first thing that I'm going to do is use Pulumi's reusable component mechanism. So let's take a look at what that would look like in action. So I'm going to create a new file. Nope, that's a folder, Lee. Come on. We're going to create a new file. I'm going to call it webapp.py. It's just a standard Python file. And I'm going to import my dependencies into here. So I'm going to do import Pulumi and then import Pulumi AWS. And then what I need to do in order to make this reusable is I start needing to use some object-oriented programming concepts. And if you're a more of on the system administrator or DevOps engineer side of things, when I say that I'm going to start using object-oriented concepts, you might immediately panic and think, "Whoa, this is a little bit too far." I come from that background too, and I'll be honest, I did a computer science degree and somehow managed to get through it without understanding what object orientation even was. You see lots of these examples like a dog or a person, and it's very rarely kind of applicable to a real world scenario, and it's often difficult to actually understand what the actual concepts are. And so what I'm going to do is show you like a real world example of a reusable component using this object orientation using Pulumi components, which hopefully will make a little bit more sense for your cloud kind of like mentality. And so let's see how that goes. A Pulumi component has two parts of it. It has the input properties, the things that you want to configure, and then it has the actual resources that you're going to create. And so I'm going to create two classes, one called web app args, like so. And
I just saw Donnie in the chat says, I mean, most developers don't even know what object orientation is. So
that's a fair
we're in
statement.
good company.
Yes, absolutely. And then because this is a object-oriented mechanism, we need to create, within Python, we need to create this init definition or this init function here. And obviously, VS Code is a little bit ahead of me in terms of what it wants to do. And then the final thing that we need to add to this is the input property. So for our reusable web application, the only thing that we want to allow people to configure is the actual image name, because we're going to be really opinionated in how this works and looks. We're not going to allow them to do, if you think about how you run applications in Amazon Web Services or something like that, there's so many input properties and it can be so overwhelming. And because we're the DevOps experts, because we're obviously followers of DevOps Directive, we are going to be the best practice implementation people. And we're going to say you're going to have a Docker image, and we're going to decide on how to do the rest of it. We're going to kind of do this opinionated implementation. So all I'm going to allow people to configure is the image. Like that's the only thing that I'm going to allow them. And so what we need to do is just make sure this is actually used. So self.image equals the image from the argument.
Mm-hmm.
And that is our first instantiation of anything in terms of a Pulumi component. So this is just the actual arguments that are going to be passed to a Pulumi program or a Pulumi reusable component. What are you, how are you following along so far, Sid? How is it looking?
Looking good, looking good. We've got one question, or we've got a couple questions in the audience, but I'll bring up the first. And Hagi says, so you're going to create an instance of what you initialize. And yeah, so the whole idea with object-oriented programming is you have this class definition, and then we can create many instances of it, and each one can have a different image name.
Yes.
So when we instantiate it, we'll specify that image, and then it'll be tied to that instance of the class. And then another question more broadly that I'll throw over to you is, what's the difference between Pulumi and Terraform?
My favorite question. So if you've used Terraform or other infrastructure as code tools, there's other things out there like Azure Resource Manager or AWS CloudFormation. Those infrastructure as code tools use configuration languages in order to actually define your infrastructure. So you may be familiar with Terraform and you've used HCL before. HCL actually is a domain-specific language which actually compiles down to JSON and its kind of native components. And I think that compiles down to maybe a little bit of a hand-wavy answer. But ultimately, they use configuration languages that are kind of procedural in order to actually define your infrastructure. Pulumi uses application programming languages in order to define your infrastructure. So right now we're using Python. We also support JavaScript languages like JavaScript and TypeScript. And I think you did an awesome Code AI implementation with JavaScript a few weeks ago, which I thought was awesome. And we also support the Go programming language and the .NET framework. So we also support C#, F#, and my personal favorite, VB.NET. Yes, that's still a thing. What's interesting about Pulumi is that you're using these kind of languages that are generally considered imperative. So you would do things like if statements and conditionals in order to actually make sure your operation, kind of proceeded in the way you wanted it to. However, with Pulumi, we're going to use these imperative languages, but it's still going to have a declarative end state. So it's still going to actually drive towards a desired goal. Even though we're using an imperative language. And once we've kind of fleshed out this particular implementation, that will become pretty clear. Some of the benefits of that are that you get a lot more flexibility in the way you define your infrastructure. For example, you can use things like object orientation if you really want to. You can do things like unit test your infrastructure as code. So like if you've used other infrastructure as code tools, like anything that's YAML based, it's really, really hard to test them without actually provisioning your infrastructure and checking that it looks the way you want it to. With Pulumi, you can write unit tests that will actually pass and fail when you make configuration changes. Once you get to a certain level of complexity, that's super, super useful because you can just unit test the changes that you're making and feel way more comfortable in your infrastructure. And then finally, you've got conditional logic. So like loops and conditionals and if statements and all that kind of stuff are all available to you. So hopefully that's a good answer. I feel like I've answered that question 1,000 times and I never do a great job of it, but hopefully that gets us there.
No, I think that's clear. I think the fact that you can use whatever testing framework you're already familiar with for your language of choice is a really unique thing that using these application programming languages brings to the table.
And I think another thing that I have felt as in my time prior to working at Pulumi and working as an infrastructure engineer is I've implemented lots and lots of different infrastructure as code tools, whether it be Kubernetes YAML or CloudFormation. And I'm working with this large team of developers that's already writing application code, so like Python or Java or all that kind of stuff. And they feel really overwhelmed and intimidated by having to learn this domain-specific language that's only reusable for one thing. And I part of the reason why I actually discovered Pulumi is that I was really trying to help enable those developers to be able to actually write their infrastructure code. And it really made a difference. The language that you're using really does make a difference. It's really easy for us as DevOps engineers to go, well, JSON's really easy to understand, or YAML's really easy to understand. But for a developer who's been writing everything in Java their whole lives, that's not necessarily the case, right?
True.
Okay, so we've defined our arguments for our web app. So now we actually need to define the web app itself. And because we kind of want to, do something that's relatively straightforward, I've decided to use Fargate today in order to actually deploy our application. So our web app is going to be deployed in Fargate using all the kind of AWS mechanisms. So what I need to do now is define a web app class which extends Pulumi.componentResource. So like we're just going to say a web app is a type of Pulumi component resource. And similar to what we did with our web app args class, we're going to define an init definition. So like these are the things that you will need when you instantiate this. And what we're going to do, if we take a look, and you'll notice that I get all of the benefits of using IntelliSense in my IDE. And so I'm going to define all the things that I actually need. So we're going to have to define the type of this resource, the name, some properties, and whether it's remote. And so what we're going to do is specify a name, which will be a string. And then we're going to specify an argument input, which of course is our web apps args, because we've already defined this, right? And then we are going to define some options, which will be Pulumi.resource options. And by default, we're not going to need any of those. So I can set a default here, like so. And hopefully you're kind of getting the idea of what this looks like. You get a lot of help from the IDE when you're doing this, right? Like if you've ever written any YAML before, even with all of the best input VS Code extensions in the world, it can really be a little bit of trial and error, right? Like you really don't know necessarily what you're going to be doing. The final thing that we need to do here is like a bootstrapping is we actually need to define what we call the token. It's really hard to explain what this actually is until we get to the stage where we're instantiating this. So I'm just going to fill this out real quick. This is pretty much boilerplate. If you're ever going to write one of these components yourself, it will make a little bit of sense. But this token is like a unique identifier within Pulumi that says, that we have actually instantiated one of these things. When we run our Pulumi program in a few minutes, I think it will make a lot of sense. Okay?
Yeah.
Okay, so what we'll do now is there's a couple things that we need to grab from our AWS environment in order to actually know where to deploy our web application. So I need to set up the name first, so self equals name, which is, of course, this property here. And then we're going to grab a VPC. So I'm going to use the default VPC for now because I don't necessarily want to, and I've just realized I made a mistake. So my IDE is helping me out here and saying, hey, Lee, you screwed something up. You didn't do something correctly. It doesn't actually know what AWS is. So let's fix that, like so.
And is that a standard convention to take your provider and map it to the name of the provider like that?
That's what I like to do. Some people like to use the from Pulumi AWS import S3 mechanism like that.
Mm-hmm.
I personally don't like that. I like to be a little bit more explicit in my code because I think it makes it more reusable when other people come along. That's the only reason. So this is, again, because we've got the flexibility of the programming language, you can kind of make your own determination on what you think is best. I like to do it this way. I think it's easier to read and easier for other people to follow along.
Got it.
Okay, so we're going to say that we want to grab the default VPC. And again, look, you'll notice that my IDE is really helping me here. So I'm going to grab the subnets as well, which we need to know, aws.ec2.get subnet IDs. Look, and I can grab the security groups. I can grab all different kinds of things if I want to. And then it will also tell me what the properties that I need to add are. So VPC ID equals. And I think this is an important time to kind of note something as well. When you create a Pulumi program, it makes API calls out to Pulumi out to AWS that says ask, in this particular case, it's going to ask AWS what the default VPC is. I could look that up and hard code it. And if you think about if you're using something like YAML and like CloudFormation, you might have some fancy functions in here. With Pulumi, all you need to do is pass the variable outputs. So like if I do dot here, you'll see that it's grabbed the VPC, and I can just look at all the different outputs that are available here and say that I want the VPC ID to come from here. And so it's a really kind of easy and straightforward mechanism. I certainly think so anyway.
Yeah, and so the VPC there is a class that's defined on the EC2 class within the Pulumi AWS provider.
That's exactly right, yeah. And so I'm just setting it up with inside this component. And I could obviously write this directly in my main.yaml, similar to what I've done here. But of course, like I want to make this reusable, so I'm going to kind of go straight from the get-go. So if you've ever deployed anything in Fargate, you'll know that the first thing you need to set up is a cluster. So let's define a cluster, aws.ecs.cluster. And I can, of course, use Python f strings in order to actually define the name of this cluster. So I'm going to call it name-cluster, like so. And then I'm going to do something that's kind of unique to Pulumi, is I'm going to make the output look pretty, which is, of course, always fun. So I'm going to set the resource options. I'm going to set the parent of this equals true. Again, when we actually run our Pulumi program, it'll make a little bit more sense. And I don't want true. I want to be self. So it will make a little bit more sense why I've done that in a few moments. Because I think without actually kind of showing you the output, it doesn't really make sense why I've set this resource option here. But we'll do another resource option in a second.
Okay.
Make sense? Cool. I'm going to cheat now because I'm looking at the time. And I'm noticing it's 9:21. And what I'm going to do is we now need to create a security group. And what this generally looks like is you do security group equals aws.ec2.security group and define it in the same way as our cluster. However, this has got a bunch of different inputs. And so what I'm going to do is copy and paste it. Simply because I'm a great software developer and I found this on our Stack Overflow. So I'm going to do this. So I'm going to talk you through what I've actually done now, simply to make things a little bit quicker.
This is mostly just to allow traffic to get to our code, right?
Exactly, but I think there's some important things to kind of make a note of here. We've got the security group ID, which I've used as an F string. And I've also, like the security group itself, when you create it, it needs to know what VPC that it's going to go into, right? And so again, I've used the VPC ID like I did here. Which has been kind of retrieved from this get VPC call. What I think is interesting about Pulumi is we already talked about how it's imperative and how it's declarative instead of imperative. What this is actually telling our security group is that it shouldn't create this security group until this value is known, until it's actually been retrieved. This is how Pulumi allows you to do things in a specific order. It allows you to do things in this way because it will grab this VPC value here and then pass it to this resource here. And because it's passing an output from one resource to an input of another resource, Pulumi knows the orderancy and it creates this dependency graph for you. Does that make sense?
It does, yeah. So it goes through and determines the ordering and which things require data from which other things.
Exactly, yes. And then the final thing, which I think is interesting, especially if you've written Python before, is that we're actually using Python's type system here. in order to actually make our life a little bit easier. So this ingress property could just be a dictionary, right? Like it could just be an unstructured dictionary, but then you would have to look up what would need to be in that dictionary, right? Like you'd have to look up what the protocol was, what the from port was, what the CIDR blocks were. And so we have added this type system to our properties, which is some of these names can get super, super long. I'm not going to lie, like they can often look a little bit unwieldy. But what it means is that when you're actually authoring this stuff, it means that if you get anything wrong, like let's say, for example, I wanted to set the protocol, and of course that's a bad example. Let's say I wanted to set the protocol to true. I can actually examine this and it'll say the input should be a string here. You'll notice how I'm hovering over. This is not a valid input for the actual Pulumi program. And so by having this type system available to us, it helps us know when we're authoring our program what the correct inputs and outputs should be. Does that make sense?
It does, yeah. And you can even set up automated linting such that you could check all your types when you're whenever
Yeah,
you have new code.
I have been struggling with my MyPy implementation because I've got so many virtual M's that it's actually not working for a change. But usually, if I set this to true, on there, like it's going to actually say here that it's not defined. But if I usually, what would happen is it would tell me that that's not a valid input for that property.
Mm-hmm.
If you think about how that looks in other kind of, especially in a YAML kind of mechanism, you would actually have to provision the resources and get the result back from the AWS API before you knew you'd made a mistake, right? Like,
Yeah.
and so it really does help you with the feedback loop of getting things correct while you're in the authoring process.
Got it. And we've got one question from the audience, a little bit nuanced around the state file and where that vpc.id value actually gets stored. So when we're running the Pulumi code, presume it's getting loaded into memory, but does that also get persisted into the state file?
It does indeed, yes. So like once we've run this get VPC call here, and once we've created these two, this is called a function in Pulumi. It's a retrieval mechanism, but the value that it gets returned, all these different outputs that we saw from our VPC, they all get stored in state, right? So you'll be able to use those and reference them to your heart's content. And then also when we create this security group, it's going to have those same outputs. It's going to have the security group ID and the security group name. All of those get stored in state too. And you can also reference them across Pulumi programs using something called a stack reference. So all of that does get stored in state. That's correct.
Cool.
Okay, I'm going to do some more copy and pasting now, Sid, because we're on time crunch. So I'm going to set up a load balancer for our AWS Fargate application, very similar to what we did before. We've used an S string for the name. We're passing the security group that we created here to the security groups for the load balancer, and we're also passing the subnet IDs. So this load balancer is not going to get created until the security group ID is known and the subnet ID is known. So again, we're creating quite an complex graph here. And then the next thing that I'm going to create is a target group. If you are following along at home, I've checked this all into GitHub. I'll share the link out into the comments afterwards. So don't worry if you, I did write this once. And so I don't want you to think that I'm just kind of like copy and paste for my living, although that is kind of what I do. So then we're also going to create a target group for our Fargate application. We're going to make sure that every application listens on port 80 because that's generally what we want our web applications to look at. We're going to say it's a HTTP protocol and then a target type of IP. And then the VPC ID is again coming from our VPC call. You can see how easy this gets if I fill this in myself. So valves.vpc.id. Like so, and if I try to set the ARN here, if my MyPy was working correctly, it would tell me that that's not a valid input, and I'm not allowed to do that, right? Okay, a couple of other resources we're going to create. We're going to create a role, an IAM role, so that our application can actually run inside Fargate. You'll notice here that I'm actually using the JSON package from directly within Python, and I haven't imported it, so let's go ahead and do that. Import JSON, which shows you that within your Pulumi programs, you can use pretty much any Python package you want. So if you have a favorite Python package that you want to use in your Pulumi program, it's totally possible to do so. I'm using the JSON package to help me create my assume role policy, right?
Mm-hmm.
Like it's gonna turn this dictionary here into JSON that gets passed to this property here, which I think is often a really, really nice way of being able to create things, right?
Yeah, for sure.
Um, final few things that I need to create here. So I'm going to create a role policy attachment, which allows my IAM role to actually run ECS tasks within Fargate. The rest of it's pretty self-explanatory. I'm going to make sure it's attached to the role itself. And then I'm going to get to the stuff that actually matters. And so I'm going to copy and paste this last one, and then we'll set up the service. We'll type that out. So what I'm going to do is create this task definition, which is going to actually run our ECS task within AWS. And again, because we're defining best practices for our end users here, I'm going to set some values for them that we could potentially make as arguments later. So I'm going to say that we're going to have a minimum CPU and a minimum memory of 256 and 512. And then if you take a look here, this is where our arguments come into play, right? So I know that I want to run a specific image as part of my web application, so I can pass this argument that I defined all the way up here, this image argument,
Mm-hmm.
and I can pass this to a property like so. So I can say my image that I'm going to run is going to be here. What we could do if we really wanted to is we could say something like we want to create a port argument and let people run applications on whatever port they want and pass it down through all of these different properties. But because we are, again, we're the experts as the DevOps engineers, so we're going to actually define best practices for them, right?
Yeah, or we could add things like the resource constraints if we wanted to specify CPU and memory. We could
Yes.
vary that across different stacks, right? If we had a dev and a production stack.
Exactly. That's exactly right. Yes. And so now I'm going to set up the actual service that's going to run this particular task definition. And it's going to be similar to what we did earlier. So I'm going to create a service like so. And I'm going to use an F string to create the name. That's not the correct way to do it. So like so. Service. Name. See, sometimes your IDE knows more about how to code than you do. I'm fairly sure at some point in the future we'll be just letting Code AI write this for us. So I'm going to pass all of the properties that I need to actually define for my service here. And what I can do is I can actually look at by using go to definition inside my IDE, I can look at all the different things, all the different inputs that need to be defined inside here, right? So
Mm-hmm.
you'll see lots of these different things are optional and sometimes they aren't. But I know, because I've already run this before, all the different inputs that I actually need to set here. And so I'm going to set a desired count of 3, like so. I know I want my launch type to be Fargate, because we are obviously defining best practices for our users. My task definition I already created earlier, so task definition .arn. And of course, I get all of the benefits of my output completion, my IntelliSense. So these are all the different things that I could pass from my task definition. I'm going to pass my IRN here. Set up some network configuration, which is where we're, of course, going to use the strongly typed inputs. So I'm going to do service network configuration args. And then you should see that I can look at all the different inputs here. Like I know that I want to assign a public IP so that it's actually going to run properly. And then I also need to define some security groups and some subnets. By using this strong typing inside the Python, and it's not the default in Python, right? Like this is not necessarily, if you've written Python before, you might not be used to strongly typed Python. But I personally really like it. I think it makes your life way easier to actually, to actually get things running.
Yeah, I
And then
think there's a little bit of work up front to get all those types in place, but once you have them and you can leverage them, it makes both maintenance and writing new code much easier.
I totally agree. And so then what we need to do for our service is define a load balancer, which of course we already defined up here in our Pulumi code. So what I'll need to do is do aws.ecs.service load balancer args, like so. And then we're going to specify the target group ARN, self.targetgroup.arn. Container name equals the name of our running container. And then we also know the port is going to be port 80, like so. And then the final thing that I'm going to do here, which I think is an interesting thing, is I'm going to specify some options, but I'm not going to specify just the parent, right? I'm going to specify more stuff here that I think is interesting. So we have this depends on input as a resource option, right? And what we're going to say is that we want to make sure that this service doesn't get created until the listener and the task definition have been created. Why have I done that, right? Well, the first reason is that this actual this service mechanism here doesn't actually have an output from this listener we created, right? Like there's no need in AWS to create an AWS listener wherever I've put it. Where is it?
It's not consuming any data directly. So your
That's
your
right.
graph
Yes.
dependency resolution can't figure out the dependency, and so you're explicitly calling that depends on, so that
Yes.
it can add that and sequence them properly.
That's exactly right, yes. And I've just actually realized that in my copy and pasting frenzy that I didn't actually add the listener. So this is a nice exercise in live coding. So I'm going to add this here, my self.listener. So because I'm not passing any of the outputs from this property to this resource here, I can use depends on in Pulumi to make sure that it will actually create things in the right order, right? Which I think is a really interesting mechanism because often there'll be times when you're creating infrastructure code where you want to do things in the right order at the end of the day, right? So this is a fully defined reusable component in Pulumi. And so we've done everything here that we need to do in order to actually create a reusable component. In a traditional infrastructure as code workflow, we would use this in our Pulumi program like so. We would do import web app like so, and then we would create app equals web app dot web app like so, because that's obviously the
The class
reusable
name. Yep.
instance. That's the reusable instance here, right? And then we need to specify a name. I'm going to call it example. And then we would do args equals web app dot web app args image equals nginx, like so, right? And I can obviously create lots and lots of these, right? I can do app1 equals example.1. This is the thing for me that started to make sense when it came to infrastructure as code, right? Like I am going to be able, with object-oriented programming, I'm going to be able to reuse this thing over and over and over again, and I can set all these different properties, and I can do this as many times as I want. This is where I personally started to kind of get an understanding of what object orientation was, because I was applying it to something that I already knew. I knew that I was going to run lots of different web apps in my Fargate instance, and this is my implementation here, right?
Yeah, the other interesting thing, right, is we could have an array of example and example one, and then map over that or do a for loop over that.
Do a for loop
Yeah,
over it and
example.
create a new web app for every single
Yep.
one. Absolutely, definitely. You know, this is really hard to do in other infrastructure as code languages or anything like that. This is a great use case of being able to do. Yes, that's exactly what it would look like. And I use this all the time in most instantiations simply because it makes your life a lot easier. And so what we would normally do here is we would run Pulumi up. Like you might put this in a CI and CD pipeline, right? Like you might, do this over and over and over again in a CI/CD pipeline. And if we go back to our code real quick, remember here how I set this token and I was like, this isn't going to make sense until I run my Pulumi program. this is where this ends up, right? So this ends up as like a unique identifier within the actual Pulumi state itself, right? And there's a couple things that I think are interesting. I've set the parent property on a bunch of these different resources. What that shows you in Pulumi is it shows you this nice dependency implementation here, so you can actually understand which thing relates to each other, which I think is nice. And this would work great, right? Like this would be a totally fine implementation, and lots of users use Pulumi in this way. However, there is another way that you can actually do this, and it's without using the Pulumi CLI as an implementation, right? So what you can do is use the automation API to create your own kind of running mechanism. And so what we're going to do is we're going to use Python's argparse to create a little custom CLI tool that we might hand to our software developers in order to run their infrastructure. So I'm going to do import argparse because I know I'm going to want to use that eventually, and I'm also going to use import sys, like so. And then what I'm going to do is I'm going to create a function called Pulumi program.
And I just want to call out one thing before we do this. If you want to go back to the webapp.py, where we actually are calling using that, or sorry, main.py is fine, but the image name we had before was just Nginx. And so that represents the actual web application that our development team has built. We're just using the default official Nginx image. I just wanted to make sure that anyone in the audience who has maybe missed that leap is like, that would we would have our own custom image there that would have our custom web app, and that is what would get used within this Fargate deployment.
Yeah, I mean, what you could do is you could actually build the Docker image locally as well, like, and actually do it as a full one-stop shop. I'm just using Nginx because I know that off the top of my head as an image name, which I think is kind of indicative of how many times I've deployed that image. So what I'm doing here is I'm defining a function that's going to be our Pulumi program rather than writing it directly in my main.py, right? So I'm going to do very similar to what I did before. I'm going to specify the image equals Nginx, like so, and I'm going to make this configurable shortly. But I think it's important to know that I'm just going to use this Nginx image for the time being. And then I'm going to do Pulumi.export. I'm going to export the URL, the DNS name, so that I know how to get to my running web application, right?
That's coming from our load balancer resource.
That's right, yeah. And I haven't defined my name yet, so I want to make my name configurable. So why don't we do that using Python's argparse? So I'm going to do argparse.argument parser, like so. Run a web application, like so. And then I'm going to do parser.add argument name metavar equals name. This needs to be a string, and help is going to be the name of your running web application, like so. Like so. And then we're going to define a final then we're going to define another argument that is going to be an optional argument that is going to allow us to destroy this particular deployment once we've finished, right? And so I'm going to do action equals store true, and the default is false because we don't want to obviously destroy our application each time. And again, if you think about how this looks in kind of a real world example, it allows you to really kind of define your own workflows within your organization. You'll know better than anybody how people get things done inside your organization. And if you can create little command line tools that will like integrate with your CI/CD pipelines, or maybe integrate with your authentication mechanisms, or integrate with your Kubernetes clusters with all the different inputs that you need. This is just one example of how this might look, right?
Yeah, and all this argument parsing stuff is just vanilla Python.
Just standard off-the-shelf Python. I'm not even going to have to install this as a dependency because I believe it's part of the Python 3 standard library at this point, right? Okay. So now I'm going to define a couple of variables. I'm going to say project name equals, I'm always going to create this in a project called web app. And then because I've made my reusable instance of this a flag, like an argument flag here. I'm going to call my stack name equals name. And then I can start using the Pulumi automation API to actually start creating infrastructure. So what I'll do is I'll create a Pulumi stack, and I'll do pulumi.automation.create or select stack. The stack name is going to be stack name, because we're going to make that configurable each time. And then the project is going to be project name. And then the program is going to be, of course, this Pulumi program, right? Like we've already defined our Pulumi program as a function here, so I can pass this Pulumi program from one place to another.
Mm-hmm.
If you think about what that's actually going to do, it's basically automating the Pulumi up portion of all of our created infrastructure, right? Which I think is, considering how that might look for most people, not having to do a bunch of YAML templates in a CI/CD pipeline, writing this as kind of actual application code or actual Python code is just a really nice mechanism, I think.
And then for anyone who wants to actually execute this CLI, they will have already needed to run Pulumi login or equivalent on their system?
They already need to actually have a place to store state.
Okay.
Yeah. The automation API is, I believe, is going to have or is soon going to have a mechanism that will allow you to do a login. So you'll just need a place to have stored your state. And then once you've done that, you can actually create things to your heart's content, basically.
Got it. And then we are defining name via this argument. We are not passing that name into our Pulumi program function yet. Do we need to refactor?
We are. What we're doing is for each instantiation of a Pulumi program, we're going to use this argument name here as the stack name, which will mean that we can run this over and over and over again. So I'll be able to do Python main.py name equals my cool app, and then I'll be able to do Python example my second cool app, and it will create a new stack for each of those, right? So that's how we're using the name at the moment.
My question is, how does the name on line 9 get defined?
It's from this argument, from this arg pass, so it's here. So args.name.
Oh, got it. Sorry. And then it's just included via a closure?
Yes, exactly. That's exactly right. Yes. I didn't actually know the nomenclature. One of the great things about working at Pulumi is you use different languages and they all have different nomenclature to define the same thing. And I'm like, what is it called in Python? And apparently it's called a closure. I'm going to do a little bit of copy and pasting because I am aware of the time. So what I'm going to do here is, if you remember when we created our Pulumi program, we did a Pulumi. It asked us for the AWS region because it's a required configuration value. So I'm going to set my US2 region here as a set config, and then I am finally going to do a print statement that will do a stack.up and then print all of the information to screen, right?
Cool.
So this is the finished, the finished implementation of a automation API mechanism, right? So what we can do now is we can do parser.add argument image metavar equals image, like so. Type equals string. Help equals the image you'd like to run, like so. And so now we can make that kind of optional. Currently, it's hard-coded to args.nginx, so I can do args.image, like so. And now I can specify my own image whenever I'm running my Python automation API program. Make sense?
It does, yeah. And if we wanted to have arguments to Pulumi program, that function, right now we don't. We're passing everything via these global args.image and args.name.
Yeah.
Could we have arguments to that function and pass them when we call that create or select stack somehow?
Absolutely, yeah. You could do image string like so, and then you could do wherever my Pulumi program is, and then we could do args.image like so. Yeah, absolutely. That's a totally valid way of kind of doing it as well. If you really wanted to. For the sake of this particular example, I've kept it nice and simple. But yes, like you have all of the full paradigm of your language at your disposal at the end of the day, right? So you can kind of do whatever you really want and kind of lay this out however you want. I've kept this really, really simple because we are obviously only have an hour. This could be a completely elaborate thing, and I've seen people do web applications with the automation API behind Flask and all kinds of different implementation mechanisms.
Cool. Yeah. I just wasn't sure because we're passing a reference to the function versus calling the function in that creator select stack. So I'm sure
Yeah.
I can look at the docs afterwards to see how exactly it would handle it, but just wanted to make sure that you could pass arguments there.
So if you look at this, input for this program, it takes a Pulumi function,
Mm-hmm.
which is a special type of function, which is a Pulumi program. But this is just a normal Python function, right? Like, so you can use these functions in whatever way you want. You can define input arguments, you can set defaults, you can do all kinds of different things there.
Cool.
Okay, so let's try run our Python application. So let's do python main.py, and we should see that we need we get some help. This is where the kind of the user experience comes in with using the automation API. And again, I've seen people do this with Flask. I've seen people do this with all different types of things. But of course, we need to actually specify a name and an image for our actual run. So let's call this SID. I'm going to run a SID application, and then of course I'm going to run Nginx. I could of course run multiple different, images, and so I can also specify help, and you'll see that I have this optional destroy flag here, which I haven't currently implemented. So let's take a look what happens when I run this. The moment of truth.
Yeah,
You see all my print statements are kind of going ahead here as well.
Mm-hmm.
So it's going to do a bunch of installing plugins. It's going to refresh the stack. And then you can see my Pulumi program is being executed in much the same way as it would have been if I was using Pulumi up. But the user experience here for anybody downstream using this kind of component that we defined is just way better. All they need to do is specify a name and an image. They don't need to write a single line of code. If you think about how this is generally used, this is generally defined by some best practice experts. You hand it over to your downstream users and say, you want to deploy your application to our infrastructure, to our well-defined platform. Here, use this Python application, or use this Go binary that I created, or use this JavaScript package that I used. The user experience is kind of way different to kind of shoving things in CI pipelines. You can, of course, use this in a CI pipeline if you want, but all you would need to do is just kind of define things as like this. And of course, you can package this up as like a standard Python CLI application. I'm just using the Python interpreter at the moment, but this is just a completely different mechanism in order to do this.
Yeah, and if people are interested in, so we're just using the standard library argparse, but there's a package called Click, which is really nice for building CLIs that could be used as well.
Yeah, I think that uses decorators, right, on the different stuff, right?
Yeah, I think so.
And you'll see, like, when we've created our web app, you'll notice that the name SID is being used here as a stack name, right? So what I can then do, and this is really useful for like multi-tenant environments, like if like lots of people are creating lots of different infrastructure that's kind of similar but not quite the same, stacks are really useful here. So I could have my own instantiation of this. You could have yours. You could have a test instantiation, which is kind of defined elsewhere. And then all we're really waiting for now is we're just waiting for all the different parts of the AWS infrastructure to be created. So it'll take a little while to create a task definition. It'll create a little while to create the load balancer. You'll see that the load balancer is creating. Those can sometimes take a few moments in AWS because they provision. Pulumi's polling the load balancer creation, and when it's finished, it will come back saying it's created, like so.
And then I think you logged out the URL as well at the end, right?
Mm-hmm.
So that's what we'll get.
Right.
And once we're
load
done.
balance is there, and here's my load balancer URL. What you can do is you can create, and I thought about doing this for this particular demo as well. You can use something like Rich to actually make way better outputs. I'm just using a super verbose output here, but you can use something like Rich, the Python package, which I think is really awesome. Python Rich. This is an awesome rich text library that will allow you to actually define way fancier output mechanisms. You could do something like create a spinner, create a progress bar, and then output the actual URL like so. Is it going to work? It's giving me a HTTPS, of course. And of course, I'm getting a service temporarily unavailable because, live things never work the way you want them to. Let's try again. There we are.
Hey.
I was trying HTTPS instead of HTTP. I think that's Chrome telling me what I'm. So that's my Nginx deployed. And of course, I can create my own instantiation of this, like so. Just create an lbrig stack, and it's going to create the whole thing again from scratch with a new load balancer and all that kind of stuff. And it's as easy as running a command line tool. Super, super simple and straightforward.
Awesome. Yeah. Let me check the chat here. We've got a question. Where can you see the resource arguments for the AWS resources?
So there's two places you can see them. We have the Pulumi.com. So if you are used to looking things up on a web application, you can see all the API docs here. So these are all the different modules we have been using. Where is it? EC2. So we created a VPC. So these are all the different inputs, like so. So here's all the different inputs that you can use, like tags and all that kind of stuff for a new VPC. That's one way to do it. The other way to do it is to, similar to what we did before, is to actually start defining your Pulumi program and then just go to definition and actually look here. So these are all the inputs and properties that you can see inside a cluster class, for example. I generally tend to use a combination of both. So I'll look things up here inside the actual API docs, which is under pulumi.com/registry packages. And you can start drilling down into all the different things that you create. So like if you're an Azure user, if you look at the API docs, these are all the different things that you can create. And we have this awesome language picker on these different resources. And so you can see how things look between Python, Go, C#, and TypeScript. So if you're a user of any of those languages, you can see examples in how to do most of those things from there as well.
Nice. Yeah, I think this gives a really good example of allowing the infrastructure team to encapsulate or hide a lot of the implementation details from the development team if they don't need to know them. So you can expose what they do need to know about and what they do need to configure without needing to dive into the weeds of all the specifics of which infrastructure is code tool and how things are operating under the hood.
And I've seen this in practice, right? Like I've asked people to write, other different infrastructure as code tools and be like, it's super easy. Just look at this example. And I've asked, developers have said, hey, I need to deploy my sample application. And we're like, well, you got to provide a bunch of JSON or YAML or other kind of DSLs. And they'll take one look at this and they're like, I don't even know what a security group is. Like, I don't know what a security group looks like. In my experience, handing them something that's already defined this, even if it's as simple as just the actual Python package, which of course could be published to pip, or if you're using npm, you could publish it as an npm package, and saying, hey, just do an npm install or a pip install and then use the actual package like that. It's just way more intuitive to application developers. And then the final thing that I'll say on that note is that it's often the case, or it certainly has been in my career, in which there's far fewer DevOps engineers in an organization than there are application developers. Getting them on your side and getting them to deploying their own applications really helps break down those silos and means that they don't have to create a ticket to get you to help them. It really reduces bottlenecks within within organizations. We have some large companies using Pulumi at the moment, and these will, if you look at some of our case studies, a great example is Snowflake, who are huge Pulumi users for our Go SDK. It's really completely invigorated their engineering organization because they can just use the languages that they're already familiar with. And I think it's really a testament to how important the input and authoring experience is for those organizations. It's such an important part of it.
Yeah, and I think the automation API is not going to be right for everyone, right? Some organizations have lots of people doing infrastructure work and modifying things and are familiar with the tools. But once you get to the point where you have a mature enough platform, you can build this and abstract away some of the nitty gritty.
Yeah, I think a lot of users, Pulumi users, start just using Pulumi up and writing Pulumi programs in a kind of CI/CD pipeline way, and then once they kind of migrate into that platform engineering type path, the automation API really kind of takes on a life of its own and becomes super super important.
Awesome. Well, I don't. We've got one more question here in the chat. Can you use Pulumi to configure like Ansible?
No, so Pulumi operates in an API layer. And so with Pulumi, you generally talk to an API and it provisions something like that. So if you have something within your organization that kind of configures an operating system with an API, then you're able to do that. What we generally see is that Ansible and Pulumi go together, whether it's putting your Ansible inside your user data or configuring things. We have something called dynamic providers, which allow you to actually insert things into the Pulumi lifecycle. Often users will use Ansible at that stage. There is this really great. The MIT folks are using Pulumi, and I can't remember the MIT DL, I think it is. Of course, I can't remember off the top of my head. The MIT folks are using Pulumi and PyInfra to actually kind of fully manage the full life cycle of their here I've found it on my other browser. So this is an example of using something similar to Ansible, PyInfra, and Pulumi to actually provision a full learning a full learning example in Python. So you can see here we've got a Pulumi program, and then they use PyInfra to actually do the operating system configuration at the VM level, which would be similar to Ansible in that level. Does that make sense?
Yeah, I've seen that pattern work well, where you have a tool like Pulumi handling the provisioning aspect, and then you have a tool like Ansible handling the configuration management.
That's right. Yeah.
Awesome. Well, thanks so much, Lee, for coming on today.
Thanks for indulging me. I really appreciate it.
Yeah, this was great. I think we made it pretty far. We did some copying and pasting to speed things up along the way, but we built
Yeah.
a simple application deployment platform in just about an hour.
I'll hop in the comments with some links once we finish kind of shutting the live stream down. But I really appreciate you having me, Sid. I think it's always fun to kind of build something together, and hopefully everybody who's watching along kind of saw some of the power of using these real languages to define things with your infrastructure.
Perfect. With that, we'll sign off. Thanks so much. Take care, everyone.